So this second part of the section number 6, section 2.6 part 2 will be about solving absolute value inequalities. Now, we have two different types of absolute value inequalities. A type that we call OR type, and then an AND type, two types. Now, the OR type is when the inequality is either greater than, if the inequality is greater than or equal. So whenever you have an absolute value inequality with these two inequality signs, you know that you are dealing with the OR type inequality. And then if the inequality signs are less than or equal, you know that you are dealing with the AND type inequality. The AND type inequality. Now, what's the difference between the two? When you have an inequality such as absolute value of x is greater than or equal to a number, you will need to create two different inequalities. So the two different inequalities, linear inequalities you will create are, the first one is created by only removing the inequality sign. By removing the inequality sign, what's left is x greater than or equal to 7 in this example. So you can see that the only difference between this one and this one is that this one has the inequality sign, this one does not. So that's for the first inequality that you will set up. And the second one requires three movements. Number one, remove the inequality sign. The absolute value sign. The absolute value. Number two, you will reverse the inequality sign. And third, you will flip the sign, change the sign of the number. So three movements: drop the inequality sign, drop the absolute value sign, reverse the inequality. If it was greater, then it turns less than, or greater than or equal, less than or equal, and then change the sign of the number. So that's why you had absolute value of x greater or equal to 7 turns out to be x, because the absolute value sign is removed. That was greater than, that becomes less than or equal. And then it was plus 7, now becomes negative 7. So that's how you set up the two inequalities to solve an absolute value inequalities of the OR type. OR type. Now, we could do the same thing for the AND type when you have less than or equal, but an easy way to set up the AND type inequality is also to set up the x in between the inequality with the negative number on the left and then the positive number on the right. Obviously, we're going to preserve the same inequality on both sides of the x value, this time without the absolute value sign. Now, after solving both, either format, either inequality type, you will be able to give the solution in all three different formats that we've seen so far: the graph, the set notation, and then the interval notation. Now, let's go over the steps when solving an absolute value inequalities, in an absolute value inequality. Number one, make sure you clear the absolute value. You get it by itself, you isolate the absolute value. Number two, you set up the two cases that we talked about. Depend on whether you have an OR type or an AND type. Solve both inequalities and then represent the solution as requested. If you are requested to present the solutions in all forms, like interval notation, set builder notation, and graph, you will do that. But first, you need to solve the inequality. And remember, the same thing that we talked about earlier is that if you multiply or divide both sides of the inequality, the inequality signs, it changes direction, it changes orientation. So now let's start with this example. In this example, it says solve the inequality. Write your solution in set builder notation, represent the solution on the number line, and then write the solution in interval notation, all the solutions. So let's see here in the first example. We are solving -9 absolute value of 3x minus 2 plus 11 greater than -10. What we want here is to first get the absolute value by itself. To do so, let's add or subtract 11 on both sides. That is -9 absolute value. Let me change the color here. -9 absolute value of 3x minus 2 is greater than -21. Let us divide both sides by -9. Well, obviously, since it's an inequality situation, this inequality sign will switch direction because we divide by negative number. So we get absolute value of 3x minus 9 is less than, that is positive 7 over 3. So this is an n-type. N-type, because it's an n-type, we can set up the expression inside of the absolute value in between. So 3x minus 9 is less than -7 over is less than 7 over 3, and then is greater than -7 over 3. Now what we're going to try to do is we will isolate the x inside of these two inequalities. Let's add 9 on both sides. Well, that is not 9, that should be 2, as it was here. That's a 2. 2. Let's add 2 on all three sides. of this inequality. So that will be, we want to have the common denominator as 3. So that's 1 here. So I can multiply by 3. Same thing here, multiply by 3. So this will be 7 plus 6. And this will be 6 minus 7. So that is negative 1 over 3 less than 3x. And then less than 13 over 3. And then to clear the x by itself now, I can divide by 3, which is like multiplying by a third. So we get x is less than 13 over 9, and x is greater than negative 1 over 9. So if you want to, since it says to graph the solution, first the set builder. Set builder would be the set of x such that negative 1 over 9 less than x less than 13 over 9. So that's the set builder. On the number line, I'm just going to choose the numbers. So say this is 0, plus it, that's going to be negative 1 over 9. Let's assume that's 13 over 9, right? On the right side of 0. So the solution will be an open circle here, an open circle here, and then the solution will be right in between the two numbers here. So solution will be between the values. And then that's the graph. And then the interval notation will be with an open circle, we're gonna have parentheses in negative 1 over 9, and then 13 over 9 with parentheses. So that's the set builder. So that is the graph, and that is your interval notation. Let's see the next example here. Same thing, we're going to try to isolate the absolute value by adding 5 on both sides, subtracting 5 on both sides. Negative 6 absolute value of 2x minus 6 is less than or equal to 81 negative. Then we can divide by negative 6. 84. That's 84. And then we divide by negative 6. The inequality sign will be switch because we divide by a negative number. So we would get absolute value of 2x minus 6 is greater than or equal to 14. Now we have this inequality. We can tell that this is an OR type. With the OR type, we will create the two inequalities, one by just dropping the absolute value, 2x minus 6 greater than or equal to 14. Or the next one will be, first we drop the absolute value, 2x minus 6. Next, we reverse the inequality sign. That's less than or equal. And then we have 14. It will be negative 14 here. So we have the two inequalities. We can solve them by adding 6 for both sides of each equation. 2x will be greater than or equal to 20. Then we divide by 2 here to get x greater than or equal to 10. 2x is less than or equal to negative 8. Then if we divide by 2, x is less than or equal to negative 4. Now, the set builder, since both inequalities, x is isolated for both of them. Now I'm going to try to give the set builder solution, the set builder format of the solution. The set builder is the set of all x values such that x is greater than or equal to 10, or x is less than or equal to negative 4. On the number line, we can graph the solution. Let me set the number line here. That's my number line. And I can say that this is 0 here. Let me put 0 closer to the other side here. That's 0. And then let me assume that this is 10 and this is negative 4. On negative 10 and on 10 and negative 4, we're gonna keep a closed circle because both are included with the less than or equal sign and greater than or equal sign. And then we see that the solution, when x is greater than 10, that means the solution lives on the right side of 10. It goes all the way to positive infinity. So this one will be from 10 with a bracket to infinity. And then the other part of the solution says x is less than negative 4. So that means we go to the left side from negative 4, including negative 4. So that means the other part of the solution will be from negative infinity to negative 4, including negative 4, which leads to the interval notation format of the solution, that is from negative infinity to negative 4 included, union from negative 10 to infinity. Now we have more practice, of course, that we can play with. Let's go ahead and play with them. We will present the solutions in the required format. Obviously, they say interval notation, number line, and then set builder. Let's go with the first example. We have negative 7. If negative 7, absolute value of 9x minus 3 plus 19 is greater than 11. Now, if we subtract 19 on both sides, we have -7 absolute value of 9x minus 3 is greater than -8. Let's divide both sides by -7. Dividing by -7 will imply that the inequality reverses. So that is absolute value of 9x minus 3 that is less than 8/7. It's an AND type. So we can set it up with the -8/7 less than 9x minus 3 less than 8/7. Now we can add 3 on all three parts of this. And then with 3, we see that it's denominator 1. We want a common denominator to combine these fractions. So that is, we can multiply by 7 top and bottom here so that we have the common denominator. Obviously, -3 gets canceled in the middle. So that is 3 times 7, 21 minus 8, 13/7 less than 9x less than, that is 29/7. Now, if we divide by 9, which is now multiplied by 1/9, we get 13/63 is less than x less than 29/63. Well, whenever it's fraction, we will not bother about giving the solution in the number line. It's going to be complicated since this is a fraction. Both fractions are close to 0. So we will not give the representation on the number line for this example. But the set builder notation will be the set of x such that 13/63 is less than x and less than 29/63. And then the interval notation is going to be parentheses 13/63 to 29/63 parentheses. The next example here. Absolute value of 7x plus 28 less than 63. Well, the absolute value is already isolated, which is good. We can identify the type now by the fact that the absolute value is already by itself. And the type is an AND type because it's a less than or equal sign. So that means the expression will be between -63 less than 7x plus 28 and less than +63. We can subtract 28 on both sides of this inequality. subtract 28 on both sides. That would give you 91 less than 7x less than 63 minus 28, 35. And then if we divide by 7 on all three parts of this inequality, we get 13 less than x less than 35. Now, the set builder, x is by itself, so we can go ahead and give the solutions. Set builder will be the set of x such that 13 less than x less than that's not 35, that should be 5, less than 5. That's 5 because it's the result of set 35 divided by 7. And then the number line, the graph of the solution, 13, well, that's negative 13. So negative 13. Negative 13, and then 5. So the solution will be in between because x is in between the numbers, and x is the variable that represents the solution, is what we're looking for. So the interval notation will be from negative 13 to 5, with not including 13, negative 13 and 5 parentheses. And our next example here is 7 absolute value of 6x plus 6 minus 14 greater than 1. Let me add 14 on both sides. That's 7 absolute value of 6x plus 6 greater than 15. Divide by 7. Absolute value of 6x plus 6 is greater than 15 over 7. So that is an OR type. Because you have a greater than or equal, both of them will be OR type. If it's less than or equal, will be N type. So the two inequalities will be 6x plus 6 greater than 15 over 7, or 6x plus 6 less than negative 15 over 7. Now, when we subtract 6 on both sides, we will get 6 canceled, and 6x will be greater than 15 minus 42. That is negative 27 over 7, or 6x less than negative 15 plus 42. So 15 plus 42. So that's negative 57/7. Now, if we divide both sides by 6, meaning that we can multiply this fraction by 1/6, multiply by 1/6, that is x greater than, simplify by 3, that is, the denominator will be 14, and then 27 divided by 3 would be -9. Or if we divide by 6 here, we would get x is less than, simplified by 3, 57 divided by 3 is 19. So that is -19/14. The set builder will be the set of x such that x is greater than -9/14, or x is less than -19/14. And the interval notation is parenthesis and -infinity to -19/14, which is from this inequality, union from -9/14 over to infinity. And by the way, you cannot reverse the whole of this. It's like you have your number line here, you get -infinity. The number, the -19/14 is smaller, so you're gonna get it first. -19/14, positive -9/14, and then infinity. So you get this inequality, this interval. This one is not included in the solution, but this is included. So that's why you have this one and this one as your solution. So you need to keep it in order as you're reading it, from -infinity to -19/14, union from -9/4 to infinity. From -9/14 to infinity. Okay, so now let's go with the next example. Our next example here is already absolute value is already isolated. We can just decide what type is that. That's a AND type. That's an AND type. So we can oh, that's an OR type because it's a greater than or equals. That's an OR type. So the two inequalities are x plus 1 greater than or equal to 8, or x plus 1 less than or equal to -8. So we will isolate x by subtracting 1 on both sides of each equation. X is greater than or equal to 7, or x less than or equal to -9. X is isolated for both inequalities, so we can give the solution in set builder notation. that is the set of x such that x is greater than or equal 7, or x is less than or equal -9. And then on the number line, let me find -9. -9 with a closed circle, and then 7 also with a closed circle. For 7, x is greater. So x is greater than 7. We go to the right to infinity, which give you a portion of the solution in interval notation as including 7 to infinity. And then the other part, it's less than -9, meaning that we are locating on the left side of -9. So that's -infinity to -9, but it's a closed circle with a bracket. So that's the graph, and the interval notation of the solution will be parentheses, well, will be the two intervals that we had here from -infinity to -9, union from 7 to infinity. So that's it for chapter 2 and section 2.6.